Alright, trigonometry. Some basic functions we're going to be using in this course are the sine function, the cosine function, and the tangent function. These are abbreviated as such: sin, cos, and tan. You'll get used to writing them like that. Now, what these functions do for us is give us some help solving for certain parts of triangle. In a triangle, if you knew two parts of the triangle outside of the 90-degree angle, which is one of the actual necessary steps to use these functions. If you have a right triangle and you know any two parts of this triangle, you can find out more information about it. If you know an angle and the length of a side, such as the hypotenuse, if you know, say, an angle, right, and you know a different side, or an angle and even the side that's real close to it, you can find out a third thing about these. Now, this isn't a video about the Pythagorean theorem, where if you know two sides of a triangle, the hypotenuse and x, a way to find the third side, the Pythagorean theorem will show you that. It's also not to solve for the interior angles of a triangle. If you know that you have a right angle, these other two angles here have to add up to 90 degrees. Now, outside of these two methods, sine, cosine, and tangent will help us find out the holes in the gaps, such as when you know two sides and you want to find an angle, or if you want to find an angle when you know two sides. Hello, Max. My son is here trying to help us. Now, if we look at this triangle here, we know this angle here, which I'm going to represent with the symbol theta. We also may know the hypotenuse. I could throw numbers in, but I'm just going to use variables to show this. Up there? Yeah, it is up there, Max. Yeah, okay. Oh, you want me to hold you? Okay. Alright, so as we solve this triangle, pretend we want to know this side over here. We want to know the side opposite of the angle. I say opposite the angle because it's on the opposite side of the triangle. So I'm going to call this the opposite side. In this one here, we're going to try to find the adjacent side. I say that because it is right next to the angle we know. And this triangle down here, this is the right angle. We know the side, this angle here. Let's actually solve for, let's solve for the hypotenuse in this one. So this is what we know. We know the angle. In this one, we knew the opposite, and we want to find the adjacent. And here we knew the hypotenuse, and we want to find the opposite. Okay, now, each one of these combinations is a little bit different. Here, the three things we're dealing with are the hypotenuse, the opposite side, and the angle. Here we're dealing with the angle, the adjacent side, and the opposite side. Here we're dealing with the hypotenuse, the angle, and the adjacent side. Now this is a very important step to identifying each triangle what you're solving with, because each one of these functions focuses on a separate thing. We use an acronym called SOHCAHTOA. Alright, SOHCAHTOA. This is broken up into three parts. It helps you determine which one of the three functions you want to use. It stands for sine of the opposite side and the hypotenuse, hype, or cosine, the adjacent side and the hypotenuse, or tangent and the opposite side, as well as the adjacent. Buttons, buttons, buttons. My son likes pushing the buttons. Now, in each one of these triangles, let's see if we can identify which ones we have. Here we have the angle. We have the hypotenuse, as well as the opposite. Now, in all cases, we're going to need to know one angle and two sides. Look at the two sides. In which grouping at the top is there the hypotenuse, or the H, and the O? Well, it's a sine. The sine has the opposite and the hypotenuse. So to solve this, we're going to use the sine. Now, I'm going to bring this all back down here so we can redraw it. Trust me, it's a right triangle. The hypotenuse we do know. The angle we do know, and the opposite we don't. To solve this triangle for whatever we do and don't know, that's an O. That's the angle. We have to use sine. And here's the way it goes. You can read it straight from this. The sine of the angle, that's what the S means, is equal to the opposite over the hypotenuse. And there it is. Now there's three variables in this. There's the angle, there's the opposite side, and the hypotenuse. In our case, we knew two of them. If there's an equation with three unknowns, you know two of them, you can plug them into the equation and solve it. Let's not worry about numbers in this video. Let's take a look at the next one. In this case, we have the opposite side, we have the side opposite the triangle, opposite the angle. We have the side adjacent to the angle, as well as the angle. So we have the angle, the opposite side, and the adjacent side. So looking at the two sides, which one of them matches up with our SOHCAHTOA part up top? O and A. Oh, in this case it's the tangent, the O and the A. So we're going to read this as the tangent to the angle. That's what the T stands for. The O is opposite, and the A is adjacent. What's that? Get it? I can't get it. Anyway, once again, three variables. As long as we know two of them, in this case it sounds like we did, we can solve for the triangle. And this last one down here, we have the hypotenuse, we have the adjacent, and once again the angle. So if we come down here, we have the angle, and the hypotenuse, and the adjacent side. Looking at the sides, we have the hypotenuse and the adjacent, the H and A. Now we use the cosine. The way it's reads, you can probably figure it out by now. The cosine of the angle is equal to the adjacent over the hypotenuse. Alright, that's a quick introduction to the way SOHCAHTOA and some trigonometric functions work. Next video, I'll show you how to actually use them to solve some.